In 1896, a Swedish physicist sat in his Stockholm laboratory performing complex calculations about how carbon dioxide in the atmosphere affects global temperatures. Svante Arrhenius predicted with astonishing accuracy that burning fossil fuels would warm the planet, cause ice caps to melt, and fundamentally alter Earth's climate within centuries. His warnings came more than a century before climate change became a global crisis, yet his groundbreaking work was ignored, dismissed, and forgotten until the catastrophe he predicted was already underway. Svante Arrhenius was born in 1859 near Uppsala, Sweden, in a family that valued education and intellectual achievement. He demonstrated exceptional mathematical ability from childhood, teaching himself to read at age 3 and mastering arithmetic before entering school. His early fascination with numbers and patterns would eventually lead him to tackle one of the most complex problems in planetary science. He studied at Uppsala University, earning his doctorate in 1884 with a dissertation on electrolytic conductivity that was initially rejected as too speculative. This early experience of having revolutionary ideas dismissed by conservative academics foreshadowed how his climate predictions would be received. Arrhenius became interested in the question of what caused ice ages, periods in Earth's history when vast glaciers covered much of the northern hemisphere. Scientists of the late 19th century debated various theories about ice age causes, including changes in solar radiation, volcanic activity, and atmospheric composition. Arrhenius focused on the role of carbon dioxide, a gas that previous researchers had identified as capable of trapping heat in the atmosphere. He understood that carbon dioxide molecules absorb infrared radiation emitted by Earth's surface, preventing heat from escaping into space. This greenhouse effect was known in principle, but no one had calculated its quantitative impact on global temperatures. Arrhenius spent over a year performing tedious calculations by hand, working through thousands of equations to model how different carbon dioxide concentrations would affect temperatures at various latitudes and seasons. He divided Earth's surface into grid squares and calculated heat absorption and radiation for each location under different atmospheric conditions. This computational work was extraordinarily laborious in an era before electronic calculators or computers, requiring absolute precision over countless hours. His dedication to these calculations demonstrated both his mathematical ability and his conviction that understanding atmospheric physics was crucial to understanding Earth's climate history. He later admitted that without the incentive of understanding ice ages, he would never have persevered through such tedious work. In 1896, Arrhenius published his findings in the Philosophical Magazine and Journal of Science, a prestigious British publication. His paper presented calculations showing that doubling atmospheric carbon dioxide would increase global temperatures by approximately 5 to 6 degrees Celsius. Modern climate models estimate the warming from doubled carbon dioxide at between 3 and 4.5 degrees, meaning Arrhenius's hand calculations from over a century ago were remarkably accurate. He recognized that industrial civilization was burning vast quantities of coal, releasing carbon dioxide that had been locked underground for millions of years. He predicted that continued fossil fuel combustion would eventually cause measurable global warming. If you want to discover more visionary scientists whose dire warnings were ignored until their predictions came true, subscribe now and activate the notification bell so you never miss these prophetic stories of genius that saw disasters coming decades before they arrived. Arrhenius initially viewed potential climate warming as beneficial rather than catastrophic. Writing from cold Sweden in the late 19th century, he suggested that warmer temperatures would extend growing seasons, make northern regions more habitable, and prevent future ice ages. He calculated that burning fossil fuels at the rate of 1896 would take thousands of years to significantly warm the planet, so the changes seemed distant and gradual. His optimistic assessment reflected the limited understanding of ecological systems and the unforeseen consequences of environmental change. He could not anticipate the exponential increase in fossil fuel consumption that would come with 20th century industrialization. The scientific community largely ignored Arrhenius's climate predictions when they were published. Some scientists questioned his calculations, while others simply found the topic uninteresting compared to more immediate research questions. The idea that human activity could alter something as vast as Earth's climate seemed implausible to most 19th-century scientists. The timescale he proposed, thousands of years for significant change, made the predictions seem irrelevant to practical concerns. His work on climate change was seen as an interesting theoretical exercise rather than a warning requiring attention or action. Arrhenius continued his scientific career, making important contributions to chemistry and physics that earned him far more recognition than his climate work. In 1903, he won the Nobel Prize in Chemistry for his theory of electrolytic dissociation, the work that had been rejected by his doctoral committee. He became director of the Nobel Institute in Stockholm, one of the most prestigious positions in European science. He published influential work on IMMUNOCHEMISTRY, cosmic physics, and the conditions necessary for life in the universe. His climate calculations remained a minor footnote in his distinguished career, barely mentioned in biographical accounts. Throughout the early 20th century, a few scientists built on Arrhenius's greenhouse effect calculations. In 1938, British engineer Guy Callendar compiled temperature records showing that global temperatures had risen over the previous 50 years. Callendar connected this warming to increasing atmospheric carbon dioxide from industrial emissions, reviving Arrhenius's predictions. However, World War II and its aftermath diverted scientific attention to nuclear physics, weapons development, and other priorities. The question of anthropogenic climate change remained a marginal topic pursued by only a handful of researchers. In 1957, Roger Revall and Hans Suess published research showing that oceans were absorbing less carbon dioxide than previously assumed. This meant that atmospheric carbon dioxide was accumulating faster than expected, accelerating potential climate change. Their work marked a turning point in climate science, establishing that human activities were conducting a geophysical experiment on a planetary scale. Charles Keeling began continuous measurements of atmospheric carbon dioxide at Mauna Loa Observatory in Hawaii in 1958, producing the famous Keeling curve that documented rising concentrations. These developments finally brought Arrhenius's century-old predictions back into scientific consciousness. During the 1960s and 70s, climate scientists began developing sophisticated computer models that confirmed and refined Arrhenius's basic insights. They incorporated ocean circulation, cloud formation, ice albedo feedback, and countless other factors that Arrhenius could not calculate by hand. These models consistently showed that increasing atmospheric carbon dioxide would cause significant global warming within decades rather than millennia. The exponential growth of fossil fuel consumption since 1896 meant that Arrhenius's 1,000-year timeline had collapsed to less than a century. By the 1980s, scientific consensus recognized that anthropogenic climate change was not theoretical but actually occurring. The Intergovernmental Panel on Climate Change, established in 1988, synthesized thousands of studies confirming that human greenhouse gas emissions were warming the planet. Temperature records showed accelerating warming, ice sheets were melting at increasing rates, sea levels were rising, and extreme weather events were becoming more frequent and severe. Every prediction Arrhenius had made in 1896 was coming true, only faster and with more destructive consequences than he had imagined. The scientific community that had ignored his warnings for nearly a century now urgently confirmed their accuracy. Arrhenius had been proven right when being wrong would have been vastly preferable. The economic and political systems that drove fossil fuel consumption showed little response to scientific warnings even as evidence accumulated. Petroleum companies and coal industries actively worked to discredit climate science and delay policy responses. Political leaders prioritized short-term economic growth over long-term environmental stability. The international community struggled to coordinate action despite overwhelming scientific consensus about the crisis. The machinery of industrial civilization continued burning fossil fuels at accelerating rates, exactly as Arrhenius had calculated would cause planetary warming. Modern climate science recognizes Arrhenius as the founder of greenhouse gas theory and the first scientist to quantitatively predict anthropogenic climate change. His 1896 paper is now understood as one of the most important and prescient scientific publications in history. Climate researchers still refer to his work when explaining the basic physics of how carbon dioxide affects global temperatures. His name appears in every comprehensive history of climate science as the pioneer who first saw what was coming. Yet this recognition came far too late to prevent the crisis he warned about. The accuracy of Arrhenius's predictions is remarkable given the limited data and computational tools available in 1896. He correctly identified carbon dioxide as the key greenhouse gas, accurately calculated its warming effect, and predicted that fossil fuel combustion would cause measurable climate change. His estimate of 5 to 6 degrees warming from doubled carbon dioxide is within the range of modern climate models using supercomputers and satellite data. He understood the fundamental atmospheric physics involved and recognized that human activities could alter planetary climate. His error was not in the science but in underestimating how rapidly industrial civilization would expand fossil fuel consumption. The tragedy of Arrhenius's story is that his warnings came early enough that action could have prevented the crisis. In 1896, fossil fuel infrastructure was far less developed and entrenched than it would become. Alternative energy sources could have been developed before petroleum and coal became the foundation of global economy. International cooperation on climate policy would have been easier before trillions of dollars in fossil fuel assets were at stake. Instead, his predictions were ignored for a century while the predicted catastrophe became inevitable. Arrhenius himself died in 1927, decades before the climate crisis he predicted became apparent. He lived to see industrialization accelerate after World War I, with automobile use and electrical generation expanding fossil fuel consumption. He published a popular science book in 1908 reiterating his climate predictions for general audiences. However, he never witnessed the global awakening to climate change that would vindicate his work. He died believing his climate calculations were an interesting scientific curiosity rather than a crucial warning. The climate crisis facing humanity in the 21st century validates every calculation Arrhenius performed in 1896. Global temperatures have risen approximately 1.2 degrees Celsius since the Industrial Revolution began, with most warming occurring since 1950. Arctic ice is melting at unprecedented rates, sea levels are rising, coral reefs are dying, and extreme weather is becoming more destructive. Atmospheric carbon dioxide concentrations have increased from approximately 280 parts per million in 1896 to over 420 parts per million today. Every trend is consistent with Arrhenius's predictions, occurring even faster than his calculations suggested. The failure to act on Arrhenius's warnings represents one of the greatest collective failures in human history. A scientist provided accurate predictions over a century before the crisis arrived, yet society ignored the warning until irreversible damage was done. Future generations will inherit a destabilized climate system, rising seas, mass extinctions, and resource conflicts because 20th and 21st century civilization chose short-term profits over long-term survival. They will ask why clear warnings from scientists like Arrhenius were dismissed while the predicted catastrophe unfolded exactly as described. The story of Svante Arrhenius demonstrates that scientific genius means little without the political will to act on scientific knowledge. He performed brilliant calculations, made accurate predictions, and published his findings in prestigious journals. None of this mattered because economic systems and political institutions prioritized fossil fuel profits over planetary stability. Climate science has provided increasingly urgent warnings for decades, yet greenhouse gas emissions continue to rise. Arrhenius's forgotten genius predicted the crisis, but humanity chose to ignore the warning until it was too late to prevent. Today, as wildfires burn, hurricanes intensify, droughts devastate agriculture, and climate refugees flee uninhabitable regions, we live in the world Svante Arrhenius predicted in 1896. Every climate disaster confirms calculations he performed by hand over a century ago. Every scientific report on accelerating warming validates his fundamental insights about greenhouse gases and planetary temperature. His hidden genius saw the catastrophe coming when there was still time to change course, but his warnings were dismissed by a civilization that valued immediate profit over future survival.